All right, we are moving our way up the ladder rung by rung, and now we've made it to the integral of cos to the fourth power theta d theta. There are different ways of doing this. Um, One way, and we showed this when we did the integral of cos squared theta d theta, is to use that basic trig identity. I won't re-derive it here, but I'll just write it down and uh, recall that cos squared theta is equal to 1 plus cos of the double angle over 2. That's one way that I can attack this problem, because then what I could do is I can square both sides. This is my abbreviation for square both sides. And if you do that, you would get cos to the fourth theta is equal to 1 plus cos of the double angle squared over 4. Okay, and then you could FOIL this out on the right hand side, etc. I'm choosing to show it in a slightly different way, just to mix things up a little bit. Here's another way to do it, so we'll do it this approach in this video. Let's write this as the integral of cos squared theta times cos squared theta d theta, and then we'll invoke our beloved trig identity, the most popular one of all, that says that the sum of sine squared theta plus cos squared theta is equal to 1. So I can therefore write this as the integral of cos squared theta times 1 minus sine squared theta d theta. Alright, and then now let's distribute so that we get, this is the integral of cos squared theta d theta minus the integral of sine, let me write this as sine theta cos theta squared. It's really sine squared times cosine squared, but that's the same exact thing, d theta. And now, if you've been paying attention, and if you've memorized some of the basic things that I've asked us to memorize, you'll recognize what's sitting in this parenthesis here. That's to say that, recall that sine, I asked us to memorize the sine of the sum formula on the angle. So sine of a plus b is sine a cos b plus sine b cos a. But if I did sine of theta plus theta, that's going to be 2 sine theta cos theta. And so if you look at this, you see that sine theta cos theta is equal to a half of the sine of the double angle. Okay, so let's go ahead and use that result in here. All right, let me just rewrite this here for a second. And let's write this, the stuff in the parentheses, as a half or sine of the double angle over 2. That whole thing is squared d theta. Okay. Well, let me write this one more time so that we get the integral of cos squared theta d theta minus the half being squared is a quarter that comes out of the integral as a constant, and then we get sine of 2 theta, and that is being squared d theta. All right, now let's do the following. I'm going to just refer us to look back at the video that we developed this one. So this one we already know. So this is, let me just write the result of that, because I can say see video. We did that. Actually, we did 2 videos, so if you don't like one of the 2, look at the other one. But so we have basically that this is a half theta plus a quarter of sine of 2 theta. Okay. All right, then we get minus a quarter of, now I'm going to do a little u substitution here. So let's say let u equal to the 2 theta, and then we have du is equal to 2 d theta. So d theta is a half of du. And so I'm going to write this as sine squared u times 1/2 du. The 1/2 du is the d theta. That's this right here. All right, and then so we're almost there. So you can see what's happening here. Well, we get a half of theta plus a quarter of sine of 2 theta minus a quarter of, what is this? The integral of, actually, a half times a quarter will give us an eighth, right? Let's bring the eighth out here. And then you get the integral of sine squared u du. Well, lo and behold, we can see the video on that one. So we actually have 2 videos that develop the integral of sine squared theta d theta, or in this case, we're replacing the theta with a u. So I can write this as 1/2 u minus a quarter sine of 2u plus our beloved constant c hat. Okay? And so if we go ahead and clean this all up, you are going to get a half of theta plus a quarter sine of 2 theta minus an eighth times, now let's stick back what u is. U is 2 theta. So it's going to be a half of 2 is just the theta. Okay. And then you get minus a quarter sine of 2u is going to be 4 theta plus this c hat constant. And then we get, let's combine like terms. So I have a half of theta and I've got a minus an eighth of a theta. So I've got, let's get the common denominator of an 8. We get 4 minus a 1 theta, and that takes care of this term as well as these 2 terms. Then if I distribute this in here, well, let me first of all write this term here. So we get plus a quarter sine of 2 theta, and then let's distribute that. So minus an eighth times minus quarter is a plus 1 over 32 sine of 4 theta, and then minus an eighth of c hat we'll just call plus c. Alright, so we get, putting all this together, we get the following. We get that the integral that we were interested in, that is to say, the integral of cos to the 4th theta d theta, is equal to 4 minus 1 over 8 is 3/8 theta plus a quarter of sine of the double angle plus 1/32 of sine of the quadruple angle 4 theta plus a constant of integration. Okay, well, I think that about does it for us right there. Thanks for watching, and we'll see you in a future video.